So in the next 15 minutes, what I'd like to cover is how do you bring these concepts that were just discussed, identity verified access from a user and their devices into a business application? How do you apply these concepts to the data center in the cloud? Because there is no user. There's certainly a device, but that's not sufficient. Um, if you have any questions throughout this, please don't hesitate to raise them in the chat. A moderator is going to ask them. So with that, I'm going to share my screen and we'll get going. All right. So what really are we trying to accomplish in the cloud and data center? We're trying to stop lateral movement. And what I mean by that is in your traditional network architectures in the cloud and data center, what you have is effectively a large perimeter with no internal controls. And I'll step away from large perimeter and say large segments. You'll often have data classification networks that will have all of your sensitive assets over here, all of your publicly accessible assets over here, and the rest over here. Or you might divide the environment by production, pre-production, development, staging, so on and so forth. The net point is there is a lot of unrelated devices inside one big flat network. And the point is that when the attacker gains access to the inside, they can more or less move freely, taking advantage of all of the unnecessary attack surface that they can see clearly because it's a big flat network. So in the world of the data center and in the cloud, how do you reduce that attack surface? In most cases, people immediately jump to micro-segmentation, which I won't assume that everybody knows what it is, even though you probably do. Micro-segmentation is really just this idea of taking the boundary that used to be around that data classification network and shrinking it around the components of the business application. So every individual business application has its own perimeter with allowed access between them. And I think that is the key. So the micro-perimeterization will take away the unnecessary access, but fundamentally to make micro-segmentation successful, you must still allow required access to satisfy dependencies. And I think where the market as a whole misses the mark is that they do not protect the allowed paths of communication. And the attackers can still move laterally by piggybacking across those paths of communication. So is this just a vendor talking, or are there real world examples of this? Definitely real world examples. Look no further than NotPetya. So NotPetya is still propagated through environments that had macro segmentation because the allowed access to access all of those file servers over port 445, one device gets NotPetya on it, it scans the network, finds a listener, exploits it, and then continues scanning the rest of the network, sometimes across those segment boundaries. Another great example would be the SolarWinds breach. You've got a monitoring system. For your monitoring system to even function, I think we can all agree that it requires access to the applications that it's monitoring. And the attackers knew that when they gained a foothold on that monitoring system, they could piggyback across all of that allowed access, and the underlying controls would not detect or prevent. So why is that? And how do we transition away from this deficient approach? And the reason it happens is because fundamentally network architectures are driven by addresses, ports, and protocols. And an address, port, and protocol is a very anonymous thing. It's not actually showing you what communicates, because an address doesn't communicate, a NIC doesn't communicate. What communicates is software. Software with a socket talks to a piece of software with a socket. So the transformation is going from address, port, and protocol to workload identity. This concept is called identity-based segmentation. So you can think of micro-segmentation as the old way of doing it with networks, address, ports, and protocols. Identity-based segmentation is the approach of doing it with workload identity. This has a lot of implications. So think about how you manage firewalls today. Oftentimes, a user, an application owner, will come to you and say, hey, can you connect my Apache server on host 1 to my MySQLD server on host 2? Network team gets it and says, I understand what you would like me to do, but that doesn't have the required information to build a policy. I need address, port, and protocol. You send the request back, and they respond with, well, This application is in an auto-scaling group in AWS. The addresses are all dynamically assigned. I can't tell you what the address is. So you can see that there's a disconnect with how administrators build policies and what application owners need the policies to accomplish. The next thing is end-to-end protection. So in the old world of firewalls, you've got multiple control points between point A, the application, and point Z, the thing it's trying to connect to. There might be 2, 3, 4, 5 different control points depending on the geographic distribution and how you segment the environment. So the administrator has to go and find all of those control points, identify the policies to modify, and figure out how to modify them. That's significant operational friction. Identity-based control is a single end-to-end policy. You modify the policy, it affects the entire end-to-end communication path, simplifying operations. Now, the last thing from an operational perspective that's majorly beneficial about identity-based segmentation is a rather nuanced point, but it is one of the most important points. It's called policy compression. Think about how you manage firewalls and other network controls. You've got a bunch of very fine-grained policies. Let's say you've got 100/32 base policies, and you don't want to manage 100 policies. So you look at the list and you say, oh, I could shrink that down to one policy using a /25 to a /25, which is great from an operational perspective. But in the process of doing that, you went from very specific policies to very general policies, which allows 26 addresses to communicate that have no business communicating. So my point is, we want to compress policies, but we don't want to undermine the security value of those policies. And with identity-based control, you can squish many, many, many paths of communication down to one policy with no loss of security, because underlying the protection is a control plane that continuously validates that it is only the authorized software and devices communicating, and nothing else. So if NotPetya gets into your environment and you've got policies set to protect your file services, when it does its scan, it will literally see nothing, because only the legitimate Windows file services client is able to even see that file server, nothing else. So how does this work? We build a fingerprint for the communicating software. We validate it on both sides of the connection in real time for every single connection, including connections that happen inside servers, like between containers inside a container host. And we do it at the sub-process level. So this is all very great concept, right? Super, super detailed. But what does it translate to? I think the best way to do that is to show you. So what we have here is a scenario. There's an app server and a database server with a firewall in between that says only the address of the app server can talk to the address and port of the database server, and only if it uses the MySQL protocol. And I'm going to watch for intrusions using an IPS, and we're going to use attacks that the IPS can detect and stop. So I'm going to use 3 very simple techniques to move laterally. And my challenge to you is, if you are considering implementing microsegmentation, why would you do it with a technique that cannot stop even the most basic lateral movement techniques? So what I'm going to do is discover the paths of communication that are allowed just using a simple netstat that shows me an established path of communication where I know your firewalls are configured to allow it. Now I'm going to piggyback over it using Telnet. I could use anything in the CrowdStrike top 10. I see this value at the bottom of the screen, which basically tells me the prefix is 5510. That's the version of the database. My point here is that the firewall cannot see into the server to determine that, oh, that was Telnet communicating and not the legitimate business application, because networks can't see into servers. So what do I do with this information? I'm just going to go download an exploit. It's very old. It's from 2012. It's called MySQL Jackpot, the 4th one in the list. Now, the firewall that we're using has a signature for this exploit, but just the same, I'm going to download it and point it at the database because there's a valuable point here. So when I do this, the connection goes through, the firewall sees it, says you came from the right address, went to the right address port, you're using the right protocol, and then it keeps watching. And at some point it says, oh, this is malicious, and it tears down the connection. So what's my point? My point is that a firewall only responds to the bad things that it observed happening on your network. They already occurred. So it has to let the connection go through so that there are packets, so it can evaluate the payload, so it can make a fingerprint that matches an IOC, and then it tears down the connection. Whereas identity-based segmentation is a pre-connect process. It only allows a connection if the verification passes, then the connection occurs. Last example. Most environments we go into, there are administrative tools littered in application environments. So a good example would be the MySQL admin command. App servers often contain these devices, this piece of software. So I take this plus a learned credential, wrap it in a shell script, point it at the database, and list all of the usernames and passwords. Firewall sees it, says right address, port, and protocol, and nothing looks wrong here because firewalls require overtly malicious actions to justify tearing down a connection. And this doesn't rise to the occasion. So the net point here is that firewalls can only detect the most extreme examples of lateral movement. And lateral movement is a much more subtle process. You cannot expect staring at a packet to tell you anything but the extreme scenarios, and that does not address the risk of lateral movement. So what do? What we do is we inventory all communicating software, building a fingerprint for the software container and device, validating it on both sides of the connection to ensure that only the authorized software communicates. So I'm going to connect the user's microservice, a Java app, to MySQLD, and let's see what happens after we apply it. So what it's telling us is that the business software and the database can communicate, but Telnet, MySQL admin, MySQL jackpot, and anything else in the future will not be authorized to communicate. So when I try to do a telnet, what do I get? Well, remember before the firewall let it go through because it couldn't tell that it was bad. But in this case, you don't even get a connection. You get permission denied. MySQL exploit, exactly the same behavior. And finally, the MySQL admin, same behavior. Meanwhile, behind the scenes, everything is happily connected. Now, I'm going to race through the final portion, which is how does this transform operations? It transforms it by simplifying it through automating the definition of policies and reducing and quantifying the attack surface reduction for you. And really, there's an unfortunate assumption, and I think it was one of the speakers just a moment ago said that you can't know everything about everything. Absolutely true. And there is an unfortunate assumption that somehow, somewhere in your organization, someone knows everything about everything in your cloud and data center so that they can even attempt to build these policies. You cannot start from zero and build the perfect policy. You need a system to present you the logical policy that should be in place that you can then scrutinize to subtract from it. We automate that process through something we call auto segmentation. It builds the segments, builds the policies, and maintains them as your environment changes. I'll be brief and show you just a glimpse. So we've got about 2.5 minutes left. And what you can see here is the first thing we do is build a topological map of the environment. So if we took Active Directory, you can see all communicating software and device into Active Directory and what Active Directory communicates to. Drill down one level and you can see everything for the an individual device within Active Directory. Drill down one level deeper, and now you've got software to software communications so that you can understand everything that communicates in the environment. You can bubble this up to a higher level, business objects, just by looking at this. And now you can see administrative desktops connecting to LSAS. One of them here, it's the CCM exec command connecting into LSAS. So you can look at it at a business level or at the low level host and software level. So what do you do with this? We automatically build the segments for you. So as an example here, let's see if I've got one already provisioned. No, I don't. So what I'm going to do is find Active Directory. And what you can see here is Active Directory, and I'm going to auto segment it to build the policies. I tell it what direction of communications to protect. I say protect everything, and we click auto segment. And what the system does behind the scenes is it builds the policy first by taking all of those identities and filtering it of anything that is known to be malicious, and then building the rest to taking the rest and codifying it into a very simple policy set. We can protect most segments with 7 policies. And in just a second, we're going to see exactly what we can do for Active Directory. In the meantime, are there any questions that I can answer? There was one that I saw that was asking about how this can apply to other capabilities that are often required in an environment, like data loss prevention, like anti-malware. Anti-malware, I think this is in server environments a great compensating control for. As you can see here, it gets to the identity level to ensure that any of the malicious software that gains access to the environment can't talk to the internet, can't move laterally, can't exfiltrate. They're effectively frozen in place. Are there any other questions that I can answer? All right. Well, the auto segmentation process just finished, so we'll keep going. The policies that it created for Active Directory, 6 policies to fully protect the environment. And this one policy handles all internal communications. Now imagine if you tried to do this with a firewall. One policy to protect all internal communications for Active Directory. It would just be an any policy and it wouldn't do anything. One policy to protect all inbound communications. So the system identified all of the services that need to be exposed outside the segment, and then identified all of the software and devices that need to be able to communicate with Active Directory. Our job as practitioners is to edit and scrutinize. So we come in here and we say, you know what? I saw Nmap was allowed. I never want Nmap to connect, and I'm going to get rid of a couple other things as well. And we click save. So instead of building from zero, you scrutinize it to remove things, which is dramatically easier for, well, administrators and generally just people trying to create things. Building from zero is always harder. So what happens when your environment changes, and how do you know that what you did is correct? You get full audit monitoring, and this is all made available to your SIEM. It gets right down to the device, the software, the address, the device, the software, the address and port, where it was enforced, and the policy that allowed it. Every connection between every piece of software in your entire environment is delivered to your SIEM or searchable in this UI. And finally, one of the last pieces of change that's critical is what happens when your environment changes, like you deploy a new service. Let's say you're going to switch to Centrify and you want to use LDAP search to talk to Active Directory. Somebody asks somebody on your administrative team to make that change. And they say, how do I know what to change? I have literally no idea. So what do? The answer is that the system will tell them the answer. So if they said LDAP search, they select it, they auto assign, and it finds the policy to modify, modifies it for them, and shows them what the impact of that change will be. They simply auto resegment and they are done. So that's about all the time I have today. Really, the net is identity-based segmentation obviously increases the security posture of the environment by only allowing authorized entities to communicate, but it also transforms your operations by having a single policy for end-to-end communications, shrinking the policy set dramatically from literally hundreds, if not thousands of policies to a small handful to fully protect Active Directory. And it brings your administrators to speak the same language as their customers, which yet again drives operational efficiency. I'd be happy to share more about this in the future. Don't hesitate to reach out, and thank you all for your time.